Hey everyone. In this video, we're going to talk about how to make and interpret frequency distribution tables and graphs. So on this slide, we have data from 47 different students, and these students took a 10-question multiple choice quiz, and we're looking at the number they got correct on that 10-point quiz. So people could have had scores that range between 0 and 10, and that's represented in this levels column. You can see that the scores go from 0 to 10. The frequency counts column is the number of people in each of those categories. So for example, 2 people had a score of 3 on the test. 8 people had a score of 7. 1 person had a score of 0. Okay? So your first column is the levels of the variable. The second column is the frequency counts. The third column is looking at the percentage of people in a given category, or the percentage of the total. Since we have 47 people in the data set, each of these percentages takes the count for a given category and divides it by 47, and then multiplies it by 100 to turn it into a percentage. So, for example, for level 6, 5 people got 6 correct. Take 5 divided by 47, and that gives you the percent of the total is 10.638% of people. Right? Or for category 8, 11 people had scores of 8. Take 11 divided by 47, multiply by 100, and it gives you 23.404%. The cumulative percentage column computes the total percent in a given category and the number of people at or below that category. So for this very the first row here, we have 2.128%. So 2.128% of people have scores of 0 or below. Then the next category is 4.255, which tells us that 4.255% of people have scores of 1 or below. Okay. Coming down here to level 6, we have 34.043% of people have scores at or below a score of 6. Right? So this cumulative percent column gives you information about percentiles there. Now, depending on which program you're looking at, you might find that your data table also has a percent column and a valid percent column. And this is because some data files might have a bunch of missing data in it. And so it's going to compute the percent differently depending on whether or not it's taking into account the missing people or the non-missing people. So is it dividing by everybody in the data file or only the people who answered the question? So in this particular case, we're using the valid percent column. We're not interested in the people who didn't answer the questions. It could be different depending on your particular research question, but in most cases, you're going to look at the valid percent column. So looking at data in tables is one nice way to visualize and look at data, but you can also look at it in graph format, which is a nicer way to get a sense of how scores are distributed. So the first graph we have here is a bar graph looking at scores. They've chosen a bar graph because this is discrete data, because you can only get a whole number correct on this quiz. There's no partial credit, right? There's no fractions, don't make sense. And so we use a bar graph to show the data here. Also, you'll notice that this data is negatively skewed. So if we look at the data points, the tail of the distribution points toward the negative side, which shows us that most people had scores on the higher end with very few people at the lower end. So when you have discrete data, bar graphs are appropriate. When you have continuous data, it's better to use a histogram, which is just a bar graph with all of the bars squished close together. They're touching each other to indicate the continuity between different categories. So in this particular case, we have students are asked how many minutes they spent completing an assignment. And so we use continuous data because fractions of minutes make sense. And so we chose a histogram here. You could have also chosen a line graph to represent these data as well. So the graphs in the previous slides were all made with Jamovi, and this slide here was made with JASP, which you'll notice looks a little bit different than this slide in Jamovi. It creates different widths of categories there. They convey the same information in different ways, and you'll find that the graphs are going to look different depending on which program you're using. If you're using SPSS or Jamovi or JASP, you're going to get slightly different looking graphs. None of these programs are meant to be creating presentation quality graphs. Typically, people create those sort of things in Excel when they have a little bit more control over the graph formatting that's going on there. But just be aware that graphs are going to look different in different programs. Pay very close attention to your X and Y axes so that you know what categories are being graphed there. Okay? And that is all we have for this video.